Hey everybody, it's Mr. D here, and I'm going to have a set of videos put on Blackboard this weekend going over the final exam and the problems you should anticipate. The first problem on my list was an amortization table. And what we have presented today is, as part of a capacity plan for 2018, a new machine is needed for the shop floor. The machine costs $150,000. You can finance it at the local bank for 5% interest. Or the company selling you the machine will give you a 10% discount if you finance through them. Their rate is 6%. Both loans will be for 3 years and you will make monthly payments. The question is, which offer is the best? To know that, we need to do an amortization table and see which machine has the lowest total interest cost. So with that, we're going to do an amortization table. The three key things you need to know in an amortization table: the principal, the interest rate, and the term or the period. For the first option, we know our interest rate is 5%. We know our principal is 150,000, not 150,000%. 150,000. Interest rate is 5%. And the term is 3 years. For any amortization table, we're going to have our payment number, we're going to have our beginning balance, we're going to have our principal, we're going to have our interest, we're going to have our total payment. Total payment, remember, is simply the sum of the principal payment and the interest payment. And then our ending balance. The ending balance is the beginning balance minus what you pay in principal. Interest is what the bank makes for loaning you the money. It does not reduce the value of the loan. All you get to reduce the loan value by is the principal. I like to use the fill command. I start with a 1 to tell it it's going to be a series. And we can go straight down as far as we want. I go up here to the fill command, choose series, and tell it to stop at 36 because 3-year payment, 12 months a year, 3 times 12 is 36. You can do it however you want. To me, that's the quick and easy way. The beginning balance for row 1 is always the loan amount, $150,000. So now we have a couple of calculations for the principal and the interest. A lot of ways to do it, but we're going to use the power of Excel and use the P payment command. The P payment command shows we need to know the rate, the number of periods, period number, present value. Easiest way to fill this in and keep it straight is to click on the function command prompt and bring up the function arguments text box. We'll fill these in. Remember, if they're bold, they are mandatory. If they are not bold, in this case the future value, we will leave those blank. We're not going to do any tricks or special calculations. If it's not bold, leave it blank. All right. So the rate is the interest rate per period. We know our rate is 5% annually, but we have to divide that by 12 to make it a monthly rate. And I'm going to go ahead and freeze with the F4 command the interest rate. The period number is the number of the period that we are in, from 1 to the total number of periods. In this case, it's this box, because as the payments proceed and as we reduce our balance, our interest goes down. So every payment amount for principal and every payment amount for interest changes by month. The total payment doesn't, but the amount for principal and the amount toward interest does. In this case, we're calculating the principal payment. Total number of periods is going to be our 3-year term times 12 months. And I'm going to go ahead and lock that total period cell at D11. And the present value is the amount of the loan. We're going to lock that in from cell D9. If you hit return here, it's a negative number. It's okay to be a negative number. I personally like it to be positive, so when I do the math, I can subtract things. Either way, as long as you do the calculations correctly, I don't care if you make it positive or negative. For interest, we're going to do an I payment, which is exactly the same. We're going to go back here to the function button, pull up the function arguments. We're going to fill this in again. Our rate, 5% divided by 12, monthly rate. And remember, as a hint, you should see a number over here whenever you do a function argument entry. It will pre-display what the answer is. In this case, 5% divided by 12 is this number. Period number, again, we're going to choose this. Number of periods is 3 years times 12. And I'm going to lock that cell. And the present value, for amortization tables like we're doing, the present value is always the loan amount. And lock that. That's also going to be a negative number. I'm going to make it positive by multiplying by -1, but it's whatever you want. You have a couple of options here for total payment. The total payment is the principal payment plus the interest. So you could just add these two cells together if you wanted to. Or you could do the PMT command, which is the built-in function of Excel to calculate the function. For time's sake, you might want to add the two, but if you want to do a double check, take the rate divided by 12. Again, I'm going to freeze it. I hit enter too soon. The number of periods, 3 times 12. I'm going to freeze it. And the present value, 150,000, I'm going to freeze it. Notice these two are not bold. We are not going to use them. It came back with a negative number. The sum of these two comes out to be 44.9563. So there's our double check. I'm also going to make this positive. All right, so now we've calculated our interest, our principal, and our total payment. Our ending balance is always the beginning balance minus what we paid in principal. Not interest, not total, but only principal. And that will give us our ending balance. And then for row 1, we need to change the beginning for row 2 or payment 2, change the beginning balance calculation. Here it's referring to the amount of the loan. The beginning balance in row 2 or payment 2 is the same as the ending balance for payment 1. All right, and we can copy these formulas down. If we did them correctly, it should calculate all the way down to 0. And it did. What that tells us is we did our calculations correct, and if we scroll to the bottom, we'll see that our principal and interest payments calculate correctly. They're changing. Our total payment did not change, and our beginning balance slowly trickles down to, at the end of our term, to 0. That's what we want. And now let's see what our interest payment would be. Our total interest payment, we can do a sum command of the interest column and choose that is the total interest we've paid, $11,842.84. So I want to copy that value over. I'm going to right click and paste the value, which is here with the clipboard with the 1, 2, 3. This was the interest for the 5% option. Instead of doing another table, I'm just going to change the values. We know that the other option was a 10% discount, 150,000 times 0.9 would be the amount, or if 0.1 is the discount, so we have to subtract that. The discount's 15,000, so we subtract it off. Be 135,000 is what we're paying for, 90% of the original price. But the interest rate goes up to 6%. The term doesn't change, and now we know, without changing anything, because the calculations remain the same, that the 6% option, even with a lower price of the machine, will cost us more money. In this case, about $1,000 more in interest. So even though they gave you a teaser and said, oh, we want you to finance from us, it's only 1% more, and we're going to give you a 10% discount, for you as a company, it actually costs you more money. So that's the purpose of the amortization schedule in this case, was to determine which deal is best. The answer to the test is do the amortization table and then say option 5 is better because our interest payments are only $11,842 versus the other option at 6% means we would pay $12,850. All right, there's your video for your amortization problem. See you in a little bit for the next one.